China's humanoid robots are now skating on ice with a balance, a precision, and a level of control that leaves even seasoned professional skaters stunned. They don't just stay upright, they perform the kind of complex maneuvers that take most people years to master, gliding and turning and landing as if they were built for it, which forces a question you may not be ready for. What happens if the next Olympic champion isn't human? Figure skating is considered one of the hardest sports a human body can attempt. It demands near-perfect balance, lightning reflexes, and constant split-second muscle coordination, all at once, on a surface designed to make you fall. And yet China has now built machines that never tire, never panic, and never lose focus, machines that, with every software update, quietly get better than they were the day before. So which is this? An astonishing technological breakthrough, or the opening moment of a future where machines outperform us at the very skills we believed were uniquely, permanently ours? Stay with me until the very end of this video, because the truth is about to reveal something far larger than a performance on the ice. The flip that should not be possible. Picture yourself scrolling through your feed, half asleep, when a video stops you cold. A humanoid robot, gleaming white, about 4.5 feet tall, rolls onto an ice rink on skates. Nobody is pushing it, nobody is steering it with a controller. It glides forward on its own, shifts its weight, and then it lands a front flip on ice. With the kind of clean, centered landing that takes human figure skaters years of daily practice to reach, your first instinct is that it's fake. A trick of editing, some clever bit of CGI. You have felt this reflex in yourself before. A clip looks too clean, so your brain files it under fake and moves on. It's a comfortable place to put it. It means nothing has to change about how you see the world. Then you notice the details a fake wouldn't bother with. The imperfect reflection on the rink, the small spray of ice chips at the landing. This is real footage. And the machine doing it isn't a classified military prototype or a $100 million experiment locked in a government lab. It's the Unitree G1. You can order one right now for $17,990 less than a mid-range luxury car. Let that price sink in, because it's the whole point. This is not a thing governments keep behind a fence. It's a product with a checkout button that a mid-sized company could buy a dozen of without blinking. But the skating isn't the part that should unsettle you. What should unsettle you is how it learned. That robot did not learn to skate the way you learn to ride a bike. It didn't fall 100 times in the cold. It didn't slowly find its balance over weeks. It learned inside a computer. A virtual copy of the real world with accurate gravity, friction, weight, and momentum, where it attempted the move millions of times in a matter of hours, until the software behind the motion was flawless. And then comes the detail that turns a fun video into something much larger. Once that skill was perfected, it was uploaded not just to that one robot, but to every identical G1 on Earth at the same time. Sit with what that means. One robot masters a skill in the morning, and every robot of its kind on the planet has it by nightfall. No practice, no repetition, a single copy-paste. A human skater who lands that flip owns it alone. She cannot give it to the skater beside her. Her body learned it, and her body keeps it. This machine has no such limit. What one learns, all of them know instantly, everywhere. So if this is what China's robots do for fun, on an ice rink, with the cameras rolling, the real question is what they're doing when the cameras are pointed somewhere else. And to understand any of it, you have to understand the trick behind the skating, because the skating was never the breakthrough. The method was why it never had to practice. It has a plain technical name, Sim-to-Real Transfer Learning, and it is exactly what it sounds like. Instead of putting a robot on real ice and letting it stumble through thousands of painful hardware-wrecking falls, engineers build a virtual replica of the world. Then they run the robot through the challenge inside that simulation. Millions of attempts, millions of failures, millions of tiny corrections, all happening faster than real time. Months of practice, compressed into hours. And the simulation doesn't just run the same fall over and over. It keeps changing the conditions, different ice textures, different speeds, different angles of approach, forcing the software to find answers that hold up across a whole range of situations, not one perfect stage scenario. By the time that skill is loaded onto the physical robot, it has already survived more edge cases than a human athlete would meet in a lifetime of training. And running those millions of attempts costs almost nothing. No broken joints to replace. No robots pulled out of service for a week with a cracked frame. Just electricity and time, spent inside a machine that never actually falls. Here's a way to feel how strange that is. You spent years learning to drive. Thousands of hours of road experience live inside your nervous system right now, and you cannot hand a single hour of it to anyone else. When you're gone, that skill is gone with you. Now imagine that every hour you spent driving quietly made every other driver on Earth a little better. That is, functionally, what this method does for robots. The learning scales. The hardware doesn't have to. That single idea rewires the whole race. In the old world, getting better meant building more machines and logging more hours. In this one, getting better means solving a problem once, cleanly, and then handing the answer to everything you have already built. And here's the part that should keep you up at night. This isn't reserved for party tricks on ice. Chinese robotics companies are running this exact pipeline on every physical skill they want a robot to own. Walking over rubble, climbing stairs, lifting awkward, irregular objects, moving through a crowd. Each one gets the same treatment, millions of simulated attempts, one perfected result, one simultaneous upload to every machine. The skating video is just the most beautiful proof that the method works. It is nowhere near the most important thing the method has produced. This is the real reason the skating should concern you. Not the flip, the fact that the flip can be copied to 100,000 machines overnight, and so can everything else they learn. Because while the world was watching a robot flip on ice, another Chinese robot was quietly putting a very different kind of number on the board. One that made seasoned engineers stop and check the math twice. If the idea of one machine's practice instantly becoming every machine's skill lands as hard for you as it did for me, type one word in the comments: insane. The morning the record stopped being human. April 2025. Beijing. A half marathon, 13.1 miles of open road. Real pavement, real weather, real race conditions. The robot beat us on the ice. A few months later, on open road, it came for a record humans had spent a century chasing, and registered among the human runners, a field of humanoid robots. Not on a closed track, not on a smooth indoor floor. The same course, the same rules, the same race. A robot called Honors Lightning crossed the finish line in 50 minutes and 26 seconds. Let that sit for a second. The human world record for a half marathon set by the most elite, best conditioned athlete on the planet, running at the absolute ceiling of what a human body can do, stands at around 57 minutes. The robot didn't just finish. It beat the human world record by more than 6 minutes. 6 minutes, at that level, isn't a margin. It's a different category of runner, the distance between the best human being who has ever attempted the thing and something that doesn't get tired, doesn't cramp, and doesn't slow down in the final mile. But that isn't even the number that should drop your jaw. Here's the one that matters more. 1 year earlier, Chinese humanoid robots ran that same distance in 2 hours and 40 minutes. 12 months, one development cycle later, they were finishing in 50. That is the 200% leap in running speed out in public on a real road. To feel it, picture a runner who finishes a half marathon in 2024 in 2 hours and 40 minutes slow, struggling, barely ahead of a casual jogger. Now picture that same runner 1 year later as the fastest half marathoner in human history. That is the curve China just posted. Now, to be honest with you, because this story deserves it, that day was not flawless. Several robots stumbled mid-race. Some needed a handler to step in. Only 38% of the robots finished fully on their own, with no human help at all. And one of the most respected names in the field, an MIT roboticist who helped build the foundations of modern mobile robotics, has looked at events like this and called them publicity stunts. He isn't entirely wrong about the distance between a demo and a working machine. But here's what that framing misses. You don't judge a trajectory by its stumbles. You judge it by its direction and its speed. A robot that needed help finishing in April 2025 is already last year's hardware. The teams that stumbled didn't celebrate and go home. They fed every failure back into the simulation and started building the next version that same week. And here's what makes the marathon genuinely alarming. Beyond the athletics, endurance, balance on changing surfaces, managing heat across sustained effort. Those are exactly the abilities that decide whether a robot can work a full factory shift, cross a messy warehouse, or keep going in an environment that refuses to stay neat. The race was never really about running. It was about proving the robots could work. A body that can carry itself over 13 miles of open road in real weather without overheating or losing its balance is a body that can survive a warehouse. That's the quiet message under the finish line. Not look how fast, look how long it lasts. But if the marathon was a test of endurance, The next thing China built was a test of something far more violent, and they were completely open about why. Getting punched is the point. February 2026. Shenzhen, the world's first humanoid robot combat league officially launches. With a gold belt on the line worth $1.4 million. The same kind of machine that glided across the ice was now being taught to take a punch on purpose. Read that again. Not a research grant, not a government award ceremony. A combat sports prize purse structured exactly like a professional fighting league brackets, bouts, crowds, cameras. It sounds absurd until you notice what it does. A prize that size pulls in every serious team in the country, hands them a reason to push their machines past the point of breaking, and lets a paying audience foot the bill for the research. The spectacle isn't a distraction from the engineering, it funds it. And what the machines do in that ring is not the clumsy, slow-motion shoving match you're picturing. They throw side kicks with real snap. They perform full aerial rotations. They take a hit, recalculate their balance halfway through a fall, and recover to a fighting stance. It looks less like a robotics demo and more like a martial arts film, except nothing is edited and nothing is faked. Now here's the detail that turns spectacle into strategy. The engineers running the league didn't hide why they built it. They stated openly, on the record, that combat testing speeds up their development cycles by 30%. Not, we think it might help. Not, we're exploring it. 30% faster, announced and confirmed. Think about what that admission tells you. They didn't build a fight club for the views. They built it because getting punched is the fastest way to find every weakness in a robot's body at once. There's something brutally logical about it. You can write 1,000 careful tests for a robot's balance, or you can let another robot kick it in the chest and watch exactly what breaks. The kick finds problems no engineer thought to check for. In a single 3-minute bout, you stress test balance under sudden impact, rapid recovery of a shifting center of mass, how limbs hold up under sideways force, and how fast a machine can react from a standing start. And every one of those maps directly onto the real world. A robot that can recover from a kick to the torso can recover from an unexpected collision on a factory floor. A robot that can spin through the air and land clean can cross an uneven surface without falling. For these engineers, combat isn't a detour away from useful robotics. It's the most efficient road straight through it. Now hold that against how the West tends to build robots. The best Western labs produce careful, methodical, heavily documented engineering, genuinely brilliant machines, but at a deliberate pace, with years between major public leaps. One approach optimizes for rigor, the other optimizes for speed. And in a race where the trajectory matters more than today's standing, the difference between those two philosophies is not academic. Neither philosophy is wrong. Rigor builds machines you can trust. But speed decides who is still setting the pace in 5 years. And only one of these two approaches is built to compound month after month. But the Fight Club was still just one arena. What China built next was big enough to hold 500 robots at once, and they called it the Olympics. The games where China wrote the rules. August 2025, Beijing. The first ever World Humanoid Robot Games, a Robot Olympics. And the numbers alone tell you this was no trade show with velvet ropes. One robot on the ice was a viral clip. 500 of them, from 16 countries, is something else entirely. 500 humanoid robots, 280 teams, 16 countries, 26 separate disciplines. 26. Let that land. This wasn't one machine wheeled out to do one impressive trick and take a bow. It was an entire competitive framework built to test everything a humanoid robot can do and then to stress every one of those things at the same time. Boxing, football, tai chi, marathon running, obstacle courses, balance challenges, each one probing a completely different set of abilities, each one exposing a different weakness for every team's engineers to take home and fix. And every one of those weaknesses, once found, goes straight back into the simulation to be solved and copied to every machine. The games weren't only a competition. They were the largest single harvest of failure data the industry had ever staged, dressed up as a sporting event. Think about what Tai Chi demands from a machine. Slow, deliberate, precisely controlled movement, which is actually harder than it sounds, because moving slowly removes the momentum that helps a body stay balanced. Now think about boxing. Explosive speed, absorbing impact, split-second reactions. Those two demand almost opposite kinds of bodies. Putting both in the same games tells you exactly what the organizers were measuring, not whether Chinese robots are good at one thing, but whether they're becoming capable at everything. And that word, everything, is the one that matters. A robot brilliant at a single task is a tool. A robot competent across many is something closer to a worker. The games were built to push these machines toward the second thing. And here's the piece most coverage missed entirely. 16 countries came, but China organized the event. China hosted it. China wrote the rules, defined the disciplines, set the judging criteria, and fielded the strongest teams. When you build the Olympics, you also build the definition of what winning looks like. China isn't only developing the most capable robots, it's constructing the international yardstick that every other country's robots will be measured against. A yardstick Chinese engineers designed. And the detail that signals real, long-term intent isn't in the 2025 event at all. Before the closing ceremony had even finished, the second games were already confirmed for August 2026. This isn't a one-time spectacle. It's an institution being built in real time, a permanent, recurring international stage where China gets to show, year after year, how far ahead its robots have moved since the last time the world looked. Which raises the obvious question. How does a country go from nowhere to everywhere in this industry in under a decade? The answer isn't talent alone. It isn't even technology alone. It's $26 billion and a 5-year plan with national security written all over it. Before we get there, be honest with yourself for a second. Watching one country write the rules, host the games, and field the best teams all at once, does that impress you? Or does it worry you? Drop one word below, worried. Today's truth, tomorrow's mistake. Here is the part the viral clips never reach. Underneath all 4 of these stories sits a funding machine so deliberately coordinated that calling it an industry undersells it. China has put $26 billion of government-coordinated investment into more than 140 robotics companies at once, running in parallel, competing against each other, feeding a national capability that no single company owns, but every company adds to. Think about what that does that Western venture capital cannot. Venture capital picks a few likely winners, pours money in, and cuts the losers early. That produces excellent companies, but maybe a dozen serious experiments at any given moment. China's model runs 140 at once. It can afford for well over half of them to fail completely and still end up with more breakthrough capability than the West's single best concentrated bet. And the aim is stated out loud. China's plan for the coming decade names humanoid robotics, a national security priority, the same category as semiconductors and military modernization. When a government files something under that heading, every institution turns to face it. Universities redirect research. Manufacturers retool supply chains. The whole system leans one direction. This is the moment to be honest about the word in the title. Concerning. Not science fiction, not robots taking over. Something quieter and more real, a trajectory. So, before you decide China has already won, there's one voice you need to hear, and it should give you real pause. His name is Rodney Brooks. He co-founded iRobot. He helped build the Roomba. He spent decades at MIT shaping the foundations of modern robotics. He is not a journalist chasing clicks or a politician chasing a soundbite. He is one of the most credentialed robotics minds alive. And he looked at all of this and called it a publicity stunt. And the honest numbers back part of his case? Only 38% of those marathon robots finished on their own. The gap between a robot landing a flip on prepared ice and a robot working a 10-hour shift under bad lighting, with unpredictable obstacles and zero tolerance for failure, is enormous. China has not closed that gap. Anyone telling you these robots are already replacing human workers at scale is getting ahead of the evidence. And Brooks has been right before, when the rest of the world was too excited to think clearly. But here's the argument his skepticism can't answer. Brooks is right about today. The question is whether he's right about the trajectory, and that distinction is everything. Because 3 things compound here. First, the trajectory itself. From 2 hours 40 to under 51 minutes in a single year is not linear progress. It's a curve that bends upward, and every stumble feeds the next version. Second, the scale. No Western company's spending comes near $26 billion running 140 experiments at once, and that many experiments find breakthroughs careful sequential work never reaches. Third, the method. Sim to real means the West can build one extraordinary robot, but China can build one extraordinary algorithm and hand it to every robot on Earth by morning at zero extra cost. That asymmetry doesn't show up in today's comparison. It shows up in the gap between where China's robots are now and where they'll be in 24 months. China went from no real humanoid robotics industry a decade ago to leading nearly every capability ranking in about 10 years. The robots aren't perfect. The skeptics aren't wrong about the gaps. But perfect was never the threshold that mattered. The only one that does is whether they're improving faster than anything the rest of the world is fielding. And on every measurable axis, they are. The Unitree G1 didn't go viral because it was beautiful on ice. It went viral because watching an $18,000 machine land a front flip and glide with more control than most of us manage in our first hour on skates, you already understood what you were really looking at. You were watching the gap close, and you were watching it happen faster than anyone had predicted. So, go back to the ice. A small white machine, gliding, turning, landing a flip. Nobody taught it because it didn't need to be taught. It learned in a simulation, and every robot like it learned the same thing the same night. That is what you were really watching, not a trick. A country that figured out how to turn one machine's practice into every machine's skill and then poured a nation's worth of money and intent behind doing it faster than anyone can follow. The concerning part was never that a robot can skate. It's that skating was the easy thing, and it already does it better than you. Everything harder is just further down the same curve. Every real leap in how machines learn has quietly rearranged the world afterward, never with an announcement, just a slow change in what became normal, until nobody could remember it working any other way. So tell me what you think in the comments, and I mean it, I read every one. Do you think the West can still catch up, or did that window quietly close while everyone was calling it a cute trick? And if this changed how you see that little clip, hit like and subscribe. That's the whole reason I get to keep making these. Somewhere tonight, a robot is skating in an empty rink, falling and correcting, and falling again inside a simulation so that by morning, every machine like it lands the flip. And most of the world is still scrolling past.